name is Shazwani Bt Ramlee. I will present about objective and background of the project. In general, frequency modulation, or as known as FM modulation, used to generate the frequency of the radio signal is changed with the line amplitude of the incoming audio signal. Next is the frequency of the carrier is changed according to the difference of signal amplitude. FM is one of the techniques to encode the data on the alternating digital or analog signal. In daily life, FM is widely used in the frequencies above of 30 MHz and significant to very high frequency or VHF of the FM broadcasting in the between of frequency spectrum of 88.5 MHz and 108 MHz. Lastly, FM is mostly used by technologies such as radars, telemeters, EEG, radio broadcasting, satellite communication, and some of magnetic tape of recording system. There are two objectives in this project. There is complete simulation design and indoor of optical wireless communication link based on the specific modulation techniques by using the Optical system, and to analyze the performance of the FM modulation characterization in the format of BER analysis, eye diagram, and the Q factor of the system.
My name is Mohamad Amirul bin Basiron, and I will present about the simulation result. Firstly, the circuit that has been designed is without the modulator. The circuit has been designed in Optical system software. This is the circuit that has been designed in the Optical system. As you can see, we are using 780 nanometer for the wavelength, and the power is 100 milliwatt. The distance parameter at FSO channel has been changed to various distance, which is from 1 meter to 10 meter, and the output from P-in photodiode goes to the low pass Bessel filter and straight to the 3R generator. The result has been analyzed by bit error rate analyzer. The result of the simulation has been shown in the table in the slide, and there is a value of a Q factor, minimum bit error, I high, and the threshold. From the tabulation result, it shows that the longer the distance, the lower the I high and the threshold. This is because of the reduction of the link loss and improve the potential of link loss. The Q factor was high and sharp in shape.
Hi, my name is Mohamad Suhairy Azhar. I will present about the indoor optical wireless, which is line of sight with modulator. This simulation are using frequency electrical modulation as its input. There is two input, which is pseudo random bit sequence generator and from CW laser with frequency of 1550 nm and power is 100 mW. The pseudo random bits goes to RZ fast generator before entering the electrical frequency modulator. Both input combine at the MZ modulator analytical before transmit to FSO channel. The output goes to pin photodiode and filtered at low pass Bessel filter. The result is taken at BER analyzer that show the reading of the bit error rate, Q factor, I high, and threshold voltage. In this simulation, the distance has minimum as testing variable to test the bit error rate, BER, Q factor, I high, and threshold value. In terms of baseband signal is typically an analog waveform without discrete and digital value. Various levels of baseband signal will be represented by various frequencies. As shown in the result, it is the table from the simulation which produce a different bit error rate, Q factor, I height, and threshold value. Okay, next I will pass the presentation to my friend. Thank you.
So my name is Nurhafizah Bt Ramlee. Today I'm going to discuss about indoor optical wireless without modulator. For part 1, based on the table 1, the simulation was designed without using the modulator. From the result obtained, it shows that the longer distance, the lower the I high and the threshold that is due to the reduction of the link loss and improve the potential of link noise figure. The Q factor was higher in sharp shape. The Q factor value reduced due to the longer distance. The Q factor will change depends on the distance length. Optical frequency modulation has been considered mainly for analog incoherently. I'm going to discuss about the indoor optical wireless with FM electrical modulator. For part 3, that is the electrical simulation with the FM modulator. In terms of electrical FM simulation, which changes in the frequency of the carrier wave correspond directly with changes in the baseband signal. This can be considered an analog form, the modulation, because the baseband signal is typically an analog waveform without discrete digital value. At this setting in this simulation, various levels of baseband signal will be represented by various frequency.
Hi, my name is Emira. Previously, you have learned about what is OWC and how it works in simulation design. Now, I will explain about the conclusion and future trends. Basically, FSO communication system were module and simulated has the system performance were analyzed when several parameters of the system were varied. Frequency modulation, called as FM, is a greater sophisticated modulation scheme than AM modulations. It is well suited to the inherent homes of fiber optic since suitable recovery of the encoded signal required the size of timing information, and this is one of the fiber strengths. FM is also immune to amplitude variations caused through optical loss and one of the fiber weakness. The heart of the FM modulator revolves around a high-frequency carrier, and now, alternatively of altering the amplitude of the carrier, the frequency of the carrier is modified in accordance to differences in the sign amplitude. For the advantage of FM system is buried in mathematical analysis that exhibit that the height to noise ratio at the receiver can be multiplied by means of increasing the deviation of the carrier. And now, in practical OWC system based on FM are regularly implemented with predetermined fixed detection threshold. However, the future trends found hard promise in the innovation of material technology and fabrications. Foundry has a properly has in the integrated optical.